Welcome to this session where we will mainly discuss the topic of carbohydrates in foods. So when carbohydrates are mentioned, we all have different thoughts and ideas about carbohydrates. Maybe for some of us, you remember immediately the toast that you had for breakfast, whereas for some of us, you might have been told at some point that carbohydrates or carbs are the main culprit for weight gain. So if you want to lose weight or to stay in shape, stay away from carbohydrates. Today, I will not be looking at the functions of carbohydrates in the human body, but rather we'll look at carbohydrates. What are they? We'll classify the different carbohydrates, which are mainly done depending, let's say, like on the number of carbons that you have. And then we'll look a little bit at the functional characteristics or the functional properties of carbohydrates, but mainly in food systems. And then we'll summarize, we'll bring this to an end with a summary. So, what are carbohydrates? Just to give an overview, as I mentioned already, so we'll look at the different types of carbohydrates, we'll look at the definition of carbohydrates, and then finally some functional characteristics of carbohydrates. Carbohydrates in general, they contain the CHO, so they have the carbon, the hydrogen, and the oxygen atoms in them. Of course, we know that carbohydrates are hydrocarbons, so it's not surprising that they've got the carbons and they've got the hydrogens in there, and they have their formula is generally CmH2n. So what it means is that if you've got, let's say, 6 carbons, you need to multiply that by 2 to get 12 hydrogens, and then you'll have 6 oxygen in your carbon formula or carbohydrate formula. They all have got these carbonyls, or you've got also the OH, so the C double bond or the OH functional groups, and they can be classified based on number one, the size of the base of carbon chain. So if you've got, let's say, a bigger carbon chain or a longer carbon chain, or you have got a shorter carbon chain, they can also be classified based on the number of sugars in the sugar unit. So let's say if you've got only one sugar unit versus if you've got 15 sugar units, each one of those will be classified separately and they will have also different names. And then they are classified according to where the positioning of these the COH double bond group is. And of course, last but not least, they are classified according to their stereochemistry. So let's look a little bit on the different types of carbohydrates. So again, as I mentioned, you can classify carbohydrates based on the number of sugars. So you can classify carbohydrates based on the number of sugar units in the total chain. Do you have one sugar unit or do you have 15, 20 sugar units? Whereby, for example, if you've got one sugar unit, of course here, one is the mono, and then saccharide just basically means a sugar. So you've got a single sugar unit will be a monosaccharide. You can have also two, in this case, where the name originates from the di. So you've got the di, and then the saccharide just means the sugar, where you have two sugar units. Or you can also have oligo, and in this case, oligo just means where you've got between 3 to 10 sugar units, and then saccharide again, it just means the sugar. And then, or you can have the polysaccharides, where you've got multiple sugar units, and in most cases, more than 10 sugar units. So, just to recap on that again, a monosaccharide is only one sugar unit, a disaccharide are two sugar units, an oligosaccharide can be between 3 to 10 sugar units, or you can have what is called a polysaccharide, where it's multiple sugar units together, and this can be more than 10 sugar units. So again, if you see, just to try and illustrate how many of those you can have. The most important thing that you need to realize is that when you have these carbohydrates, when we looked at the proteins, we said you have amino acids as their building blocks. So you have different 20 amino acids in nature. And then when you want them to interconnect, you'll need the peptide bonds to bring them into interconnections. But contrary now, when you have the carbohydrates, the linkages or the things that bring them together, that they make them to stay together or connect together, are known as the glycosidic bonds. So sugar chains are mainly connected together by these glycosidic bonds. So like to show you an example where if you've got glucose and you have another glucose, you pair these together, you end up with a maltose, or you have galactose and you have glucose, you pair them all together to end up with a lactose, and I'll talk about that in a minute. That bond that brings one sugar with another one, that makes them to want to stick together to give you these bonded, or to give you these multiple sugars in them, that's the glycosidic bond. So here again, you can see there is, for example, here an alpha glycosidic bond that connects the glucose to glucose, or they can be the beta glycosidic bond that connects the galactose to glucose. So again, now we try to look at the individual sugar molecules, or let's say to classify the different, to look a little bit more in depth with the different carbohydrates. So we said when you have only one sugar unit, this is called a monosaccharide. And just something that I'd like to highlight here is that like the sugars, or when you've got these monosaccharides, they are the building blocks of all carbohydrates. So for example, if you want to make a disaccharide, definitely you need a monosaccharide and another monosaccharide to be connected by the glycosidic bond, and this gives you a two sugar unit or a disaccharide. If you've got a three sugar unit, you can have 4 sugar units, you can have 13 sugar units, and all those are able to come together as building blocks to give you all the different carbohydrates. So in nature, we've got three different monosaccharides, or examples of monosaccharides are glucose, and then we've got galactose, and then we have fructose. So if you've got, for example, a sucrose, which I'll come back to in a minute, is going to be a connection of monosaccharides, and they need a given type of linkages. But just to show you, when you're starting up in nature, you'll always have the glucose, galactose, and fructose are the three main types of monosaccharides. One thing to remember here is also that all monosaccharides are called, or also known as, reducing sugars. So they can be used as reducing sugars in different reactions. And then when it comes to disaccharides, as the name suggests, di means two. So you've got two sugars coming together, and these two sugars, like in this case, we've got a connection there, which is a glycosidic bond, another glycosidic bond, another glycosidic bond. So if you've got glucose and glucose, bringing these together via the formation of a glycosidic bond gives you maltose, or you can have glucose and galactose. When the two of them come together, they give you what is known as lactose. And lactose is basically the sugar that is usually found in milk. If you've ever heard of somebody that they will say they've got lactose intolerance, it's just because their bodies do lack an enzyme called lactase. And this enzyme lactase is what is responsible. Of course, when you drink the milk, it's more of like a complex sugar. Your body will not be able to break it down easily. It needs to be broken down into the individual constituents so that it can be absorbed in the body. So if you have like glucose, we know that glucose is the energy again that the body needs. So you need those individual sugars or simple sugars for absorption. But then in this case, for the people that have lactose intolerance, what happens to them is that they lack these lactase enzymes. So when they drink milk, they are not able to, the body cannot be able to break it down because of the lack of that enzyme into the individual constituents of monosaccharides that enables or aids with the digestion. So again, that can be an issue when it comes to people that are intolerant to the sugar that is present in milk. And then, of course, we know sucrose is just the normal sugar or table sugar that we use in our day-to-day functions or day-to-day applications. And sucrose is made by bringing together glucose and fructose. And again, there is there's the glycosidic bond that connects the two of them together. Then we have oligosaccharides, as I mentioned already in a couple of slides before. These are mainly sugars that will be between 3 sugars to about 10 sugars. The oligosaccharides are present, again, carbohydrates that contain between 3 to 10 sugars, single sugars or simple sugars. They are not relatively abundant in the diet. So when you compare, let's say, these oligosaccharides to things like disaccharides, things like lactose, sucrose, or maltose, they are not as relatively abundant in the diet. And so in that case, you'll find that maybe not so many times people talk about oligosaccharides. And then some of the common oligosaccharides include things like raffinose, citrus, and verbascose. And of course, this is something that we'll discuss a little bit in more details in another session. Then the final classification are the polysaccharides. The polysaccharides, they are also called glycans, and they mainly have a molecular structure that can either be a branched structure or can be a linear structure. As the name suggests, the linear, of course, is just the way the different sugars are arranged, and I will show an example in a couple of slides to come. Or you can have the branched structure, which again depends on how the sugars are arranged. So the linear branched polysaccharides, they include things like cellulose, which often pack together to form a rigid structure, and sometimes breaking down these structures can be difficult. And then when you have those branched forms of polysaccharides, these are mainly soluble in water, things like gum arabica, and they're mainly used for thickeners or as thickening agents to make things like pastes, etc. So let me just highlight in these next slides the differences between the linear and the branched polysaccharides. So again, you can see here the different sugar molecules. So the first sugar molecule is there, the second sugar, the third, and the fourth. And of course, these are connected, interconnected. There is, of course, this glycosidic bond here, but they are mainly connected with what are known as, if I highlight that, what are known as, so here I'm trying to point out the alpha 1,4 linkages. So you've got these alpha 1,4 linkages there, you'll have another one there, you'll have another one there, etc. And those linkages bring them together, and it's just like in a linear form. But again, as we say, they tend to be much more rigid, and at the end of the day, much more difficult to deal with in terms of like solubility. When it comes to those branched polysaccharide, as the name suggests, again, they've got all these different branches arising from them. So again, if I try to highlight here, you can see this is a separate branch, is another separate branch coming from, like, if we call this as the main chain of your carbohydrate. And you see here in these illustrations, you can have either alpha 1,6 linkages or alpha 1,4 linkages that can come together as the linkages that are needed to connect these different sugars together. So again, just to highlight or to summarize or to recap, so you've got either the linear polysaccharides or the branched polysaccharides, where the linear polysaccharides are connected by alpha 1,4 linkages, whereas when it comes to the branched polysaccharides, they will have what are known as the alpha 1,4 linkages as well as the alpha 1,6 linkages. So when you're looking at the different applications of carbohydrates in food, again, as I mentioned at the beginning, if you're looking at these applications, let's say from human body perspective, you'll have a different focus. You look at the source of energy, etc. Whereas if you're looking at these from a food application part of it. You're looking at them, how they are mainly involved in aspects to do with food processing. So you can look at things like solubility. As I mentioned, the branched polysaccharides tend to have a better solubility and can be used as thickeners in given samples. Things like cryoprotection, so to protect when you're freezing the samples. Some of them can have a sweetening effect, like we know sucrose, which is our table sugar, can be used as a sweetener. You can have fructose, again, is used in different products as a sweetener as well. They have got what is known as hygroscopicity. They can be crystallization inhibition, flavor encapsulation, or fruit cutting ability. And these play different roles when it comes to the applications in the food industry. So to bring this carbohydrate summary in to an end, this session to an end, I'll just like to recap on what we've talked about today and to summarize what we have discussed. So we've looked at today carbohydrates. So again, if I try to highlight these, we looked at the different carbohydrates. If you want to, let's say, look at the big branch here, and then once you've done that, you can end up with the carbohydrates either having, if you've got, let's say, one sugar in there, that one sugar will be a monosaccharide. And typical examples of monosaccharides are glucose, we have fructose, and we have galactose. And these glucose and glucose can interact, or glucose and fructose can interact, or galactose and glucose can interact. So you can have glucose and glucose giving you maltose, or you can have glucose and fructose connecting to give you sucrose, or you can have glucose and galactose coming together to give you lactose. And we say lactose is usually the sugar that is present in milk. And for those people that find it difficult to drink milk, is mainly because they lack the lactase enzyme. Again, here looking at this, highlighting, you just have a single sugar, and that single sugar is what constitutes that sugar. In this case, you might have, let's say, 6 carbon chains, 12 hydrogens, and 6 oxygens, and these come together, give you the sugar unit. And in one of the other sessions, we look at how the different structures of these monosaccharides. I mentioned, if you're going to have, let's say, glucose and glucose, what do you end up with? We've got some lactose, we've got maltose, we've got lactose, and of course, you've got sucrose. These again are two sugars. So you've got, let's say, sugar number 1 here, you've got sugar number 2 here. And the most important thing to think about here is that glycosidic bond. So again, something to highlight, that when you've got these two sugar units coming together, they can be connected somehow, and this interconnection gives you that gives you the disaccharide. And then I've skipped literally talking about in this summary the oligosaccharides. As I mentioned, oligosaccharides are mainly seldomly present in food systems, and so I'm just going to look mainly into the polysaccharides, which are things like starch, and starch are just many multiple units of glucose. You can have glycogen, or you can have cellulose, and these are just many sugar molecules that are linked together. So when these sugar molecules connect together, they're linked together one with another. These nicely come together and can give you these polysaccharides. And polysaccharides, again, can be used for different roles and for different functions within the food industry. So hopefully that was kind of like a good overview of a summary of carbohydrates. And then when we look in the next session, we look at the different structures, and then we look a little bit more into details, mainly on the polysaccharides, because you might have heard of the term hydrocolloids, so which are like polymers that can be able to bind with water to give, once they bind with water, they can have different functional characteristics, and we'll look a little bit more into details with that in another session.